Hi, my name is Stuart Lynch, and in this video I'm going to show you how you can install and work with the Firebase Emulator suite on macOS for use with an iOS project. The sample project is written for SwiftUI, but the information provided will apply to projects written in UIKit as well. Now before I get started, let me request that if you enjoy the video, please leave a comment below and give it a thumbs up. Also, subscribe to my channel and make sure you ring the bell to be notified of new videos. If you want to support my work, you can buy me a coffee. If this is something you want to learn, then keep watching. I currently have a Firebase project set up for this video, so if you want to follow along with the video using the sample SwiftUI project provided in the link in the description, you'll have to create your own project. First, in the project, change your bundle ID to match your own organization name. Next, create a Firebase project in the Firebase console using your updated bundle ID. Make sure you generate the Google Services info.plist file and add it to the Xcode project, as it's missing from the repo that you've downloaded. On the Firebase console, add an iOS app and make sure that you add authentication using email and password. And you can see that I've been using the app already and have 6 different users. You'll also need to enable Firestore database. Now there's no need to set up the users collection, as the app does this for you when you create a new user, as you'll see in a minute. There is a document here for each of us 6 users. And you can set up rules like this here, where we ensure that we only read and write from the database if the user has been authenticated. And finally, you'll need to enable storage, because we'll be giving each user the ability to update their profile image. Again, no need to set up the bucket, as the app does that for you. And you can see that all 6 users have already updated their profile pic, and the rules here are the default set. So let's see how the app works. If you have an account already, you can log in. Once logged in, it fetches your name from the users collection in Firestore, and then it fetches and displays the corresponding profile image. I'm not doing any asynchronous download here, so it is slow, but this again is just a sample app. You have the ability to update your profile image from the photo album and scale it to meet your needs. You can also delete a record, but this is a production database and I don't want to do that. You can also create a new account by entering your full name, email address, and password. Once created, you can choose your profile picture. If we return to the console, we see that the new user is in the Authentication tab. A new document entry has been entered into the Users collection, and a new image is in the Profiles bucket in storage. Of course, we could have verified this by going back to our app and trying to log in as that user to see if the information is displayed. Now, I have to emphasize that this is not a fully developed project. For example, I don't handle errors very well at all, and the user gets no notification. I put the project together just for the purpose of this video, so that I can demonstrate setting up emulators for authentication, Firebase Firestore, and storage. So why would you want to set up an emulator suite? Well, remember I said that I didn't want to delete that user because I was working in a production app. Well, sooner or later you're going to be releasing your app, or you're in development and you have data in the production Firebase project that you don't want to risk deleting or corrupting. Or perhaps you're traveling and don't have an internet connection and want to work locally on your app. These are good reasons to install the emulator suite so that you can run your app locally without an internet connection or endangering production data. So let's see how we can do that. To install the emulator suite, you'll need to install Node and Node Package Manager. And the easiest way to do this is using Homebrew. Now I'm currently running my main computer, which is an M1 Mac Mini running Big Sur. But I've also installed it on my M1 MacBook Pro that's running Monterey, macOS 12. So for the purposes of this installation process, I'm going to have to show you how to do an install on a virtual machine hosted by Parallels Desktop. So it's a clean installation of Monterey. So the first thing I'll have to do is install Homebrew. You can visit the Homebrew site here at brew.sh and copy the installation code displayed on the main page. Now all of the code snippets and terminal commands used here are listed in the full instructions that go along with this video, and they can be found at the link provided in the notes below. Open a new terminal window and paste the code into the terminal and press enter. Enter your password as required and follow the prompts until Homebrew is installed. Now this will take quite a while, so I'll speed up the video to save some time. You now need to add Homebrew to your path, and you can do that by copying the 2 lines of code that's displayed in the console and press enter each time. The code reflects your account, so make sure that you copy it from the console. Now you can check which version of Brew is installed using brew-v. Next, you can use Homebrew to install Nodejs, and you do that using the following terminal command: brew install node. Now before I check to see what versions are installed, I'm going to do a Command K to clear the console. So once it's complete, you can check out the installed versions of Node and Node Package Manager. Node-v shows me the version of Node that's installed, and npm-v shows me the version of Node Package Manager. Now you have everything you need to install the Firebase tools, which gives us the emulator suite. To install Firebase tools, we'll use Node Package Manager with the command npm install -g firebase-tools. I see after installation I'm getting some errors, so I'm going to do what they say to address the issues. I'll update Node Package Manager first. And now it suggests that I run this audit fix. This doesn't seem to work, so let me follow the next selection to create a log file. Now I can run that fix once more, and I have no more vulnerabilities. We can check to see what version of the Firebase tools we have. So let's clear the screen once more, and I'll type Firebase --version. So in order to access your Firebase projects, you'll need to be logged in as that user. And we'll do that in the terminal by entering Firebase --login. You'll just need to step through the prompts to complete the login process. A web browser will open for you to authenticate. And in my case, I have 2-factor authentication, so this requires me to open up my Gmail account on my mobile device to confirm. So I'll do that. If all goes well, you'll get a success notification in the console that you're logged in. You next need to create a project folder on your computer that will host the configuration files. So I'm going to do that, and I'll call mine Emulators. In Terminal then I can change the directory to that folder by doing cd space and then simply drag the emulators folder onto the terminal window and then press enter. Let me clear the screen once more and issue the Firebase init command. And it's Firebase init emulators. Since I'm logged in, I can choose to select an existing project. And I can use the arrow keys to move up and down in the terminal window, and I'll select the one that is using an existing project and hit enter. I'll arrow down to select the project that I want to access, which is this one here, the sample Firebase project, and press enter. I'm next asked to decide which emulators I want to set up. Well, we've got 3. So I'll use the arrow keys to move up and down and then press the space bar to select the emulator. Once you have them selected, you hit enter one more time. Accept all the default ports and answer Y or yes to enable and download the emulators. Next, you'll need to initialize all of the emulators, except for the authentication one. For this, we'll use the Firebase init command, and then we'll enter storage and hit enter, and then it will initialize storage and recognize that there is a rules file on our server, so it will download that to my configuration folder. To initialize Firestore, we'll use Firestore, and again, we'll download the rules and any indexes. All the files that are downloaded are stored in the configurations folder, so we could edit the rules right here. You're now able to start your emulators with the emulators start command. So we'll return to the terminal application and make sure that we're inside the folder where the configuration files are, and we'll type in the Firebase emulators:start. Now, I'm not getting a successful launch because Java is not installed on this virtual machine, and it appears it's not installed under Monterey on an M1 Mac. So we'll have to install Java because the Firebase Emulator suite needs it. Now, if you're on an Intel-based Mac, you can just go to the Java site and download the Mac installation and install that. However, with me being on an M1 Mac, it's an ARM 64-bit chip. So for this, I'll need to go to the Azul site to download the correct installer. So I'll scroll down and locate the ARM 64-bit version and download the DMG file. Once it's been downloaded, I can execute the package to have it installed. After successful installation, you should now be able to execute the Firebase Emulator Start command to present the successful startup display in the console. So I'm going to copy this emulators folder over to my real live machine now that's still running Big Sur and issue that command in the terminal there. This time I have a successful launch and we're told that the emulators are ready and that I can connect my app. I can view the emulators with a UI at the local host on port 4000. You see here that we have access to each one of our modules. You'll notice that there's no content yet. The only thing that we have are the rules provided by your project, and the plist in your project will access the emulators instead as long as we tell it to do so. Now, I've done a lot of testing, and I found that the rules and indices for Firestore work as designed. But in the version that I've installed, the rules for storage cause a problem when trying to upload an item to the storage bucket. It can read items, but when I attempt to store, either the emulators crash or it gives me a permission error. I've verified that this is a bug, and I've submitted a bug report to the Firebase team, and they've acknowledged it, so hopefully there will be a fix soon. But the solution I discovered that will work for me for now is to remove any conditions on that local copy of the storage rules. And since we're working locally on an emulator, it doesn't really matter that the rules aren't exactly the same ones. Now, I usually use Sublime Text as my text editor, but let me open it in TextEdit here. And I'll just remove this condition that restricts reads and writes to only authorized or logged in users. After removing this, we can save the file. And when you update the rules, there's no need to restart the emulators. You can see that the console will recognize that the changes have been made. Now we want to be able to switch easily between using emulators and the production server. So what I suggest you do is to create a custom configuration for that. And I have an entire video on custom configurations and compiler directives that I'll leave a link to in the description below. And the way that we'll do this is to duplicate the debug configuration and add our own special flag just for it. If you select your project, not the target, you can see the two configurations that are there by default in the Info tab. If you tap on the plus button, you can choose to duplicate the debug configuration. So let's do that. And I'm going to rename it and call it Emulators. With the project still selected, I'll switch to Build Settings and search for Swift Flag. Make sure that the All is selected. You should now see Swift Compiler Custom Flags. And if you select other flags and expand it, you'll see the three different configurations. None of them have a flag attached to them. But we can select the emulators configuration, and in the space to the right, I can enter my own flag. A custom flag starts with -D, and then it's followed by your own flag name. So I'll use emulators, and that'll all be in capitals. Next, we'll need to modify where we've configured the Firebase app. In SwiftUI and Xcode 12 and higher, that's normally done in the file decorated with the @main attribute. In UIKit, or even within SwiftUI, you can create an app delegate though. So just make sure that you're where you configure your Firebase app. First, we'll need to import Firebase Auth and Firebase Storage because we're going to need that if we're going to be using our custom flag. We can use our custom flag as a condition. So we'll use the hashtag #IfEmulators, else if debug, end if as our conditions. I like to have it printed to the console to let me know what I'm accessing. So I'll use a multi-line print statement within the condition and print information to the console. We're not going to do anything with the debug selection, but we do need to add content to the emulators condition. We're not paying any attention to the release because release will be just like we're doing with debug, nothing. If you visit the Firebase documentation page, in the Build menu, we can choose Emulator Suite. You can read the documentation for each of the three different emulators. In each, there's information on what is needed to be added when using Swift. I've already copied this code to my clipboard. Back in Xcode, I can paste that after the print statement on the emulators condition. Now when we run our application, we can choose which configuration we want. The default is debug, but we can choose our own custom configuration based on that flag. And we can do this by choosing Edit Scheme from the Product Scheme menu, or you can simply choose your app and edit the screen directly from the toolbar, but it's also worth noting that there is a keyboard shortcut for this, which is Command <, or Command-Shift-, comma. And when you select this option, you can see that you can select Run on the left side with the Info tab, and all of your configurations are there. And you can choose your custom one, our emulators. Now when it runs, we can see displayed in the console that we're testing on the emulators. So let's verify that. Let's try to log in as that user we created on the live server. I see that the console is telling me that there is no user with that information. Remember, this is just a sample app, so if this were a real app, we'd want to be presenting an alert to the user with that information. So let's create a new account for that user. Once I've successfully created the account, I'm logged in and can go ahead and choose a profile image. If we check out our emulator console now, we can go to the authentication emulator and see that the account has been created. Going to the Firestore emulator reveals that there is a new user document for this user, and the user collection had been created. And then finally, going to the storage emulator, we see that the profiles bucket's been created, and inside there is that image that we uploaded using the ID that is the user ID. Let me run the app just once more, and I see that I'm still logged in as that user, and the profile image gets loaded. Let me create one more user. Let me choose a profile image, and then log out. Logging back in again shows me that the second user has been created and the image uploaded. And the emulators can confirm that. Now we need to test whether or not we can update or delete records from the emulator suite. Back in the simulator, I can make sure that I'm logged in as that user and tap the Delete Account button. This requires re-authentication, and if I successfully re-authenticate, I'm now given the opportunity to delete the account. So let's do that. Returning to the emulators then, you see immediately that the profile image disappears. There's one Firestore record left now, and the authentication emulator shows just that one user left. Looks like we have it fully functional using the emulators. Now I'm free to create, update, and delete records on my system without having to worry about having an internet connection or messing around with live data and potentially corrupting it, if this were an active project. I hope you found this useful and will be able to use the information in your own projects. Thanks for watching.